For this example, we're going to be writing a polynomial in standard form with the following roots: x equals 4 and x equals 1 plus I. I notice that one of the roots is a complex number because of the imaginary unit I. So every complex root comes in a pair. So if I look at the reminder here, the complex conjugate, if the root is a plus bi or 1 plus I, then you have a conjugate a minus bi or 1 minus I. So there's my three roots. So the first thing I'm going to do is write this in factored form. So to turn a root like x equals 4 into a factor, I would have x minus 4. To turn this into a factor, I would have x minus this, which has two terms. So I'm going to put it in parentheses, 1 plus I. And lastly, to turn the final root into a factor, I would have x minus this, and again, parentheses because it has two terms. All right, I'm going to focus on these two factors, and I notice that there's a -1 that I can distribute here to both terms. So I have x minus 4, and then x, -1 times 1 is -1, and -1 times I is -I. For the final factor, I notice that again I can distribute a -1 to both terms. So I would have x, and then -1 times 1 is -1. -1 times -I is +I. All right, so right now I'm going to ignore the x minus 4 for a second, and I'm going to focus still on these last two factors. And what I'm going to do is I'm actually going to throw in some parentheses around the x minus 1s. And the reason I'm doing that is you're going to notice a pattern to help you multiply both of these together quickly. If you distribute now, you would start with the x minus 1 and you would distribute that to both terms in the second parenthesis. So I would have x minus 1 times x minus 1, which is x minus 1 squared, and then x minus 1 times I. However, when you distribute the -I to this first term, you're going to see a zero pair. So remember we had x minus 1 times I, and now if I distribute, I would have -I times x minus 1. So your middle terms will cancel out here. So essentially, to make your work a lot easier, all you have to do is multiply this first pair and then this last pair. So x minus 1 times x minus 1 is x minus 1 squared, and -I times I is -1I squared. So I'm going to continue to simplify this, and again, we still have to multiply it by the x minus 4. So x minus 1 squared is x minus 1 times x minus 1. And then I have -1 times I squared. I squared, you could actually plug in, I squared is -1, so I could plug in -1 there. So this is -1 times -1. So let's simplify this. Let's distribute the x to both terms. X times x is x squared. X times -1 is -1x. Distribute the -1 to both terms. -1 times x is -1x. And -1 times -1 is +1. And then this double negative makes a +1. So it looks like I can combine -1x minus 1 more is -2x's. And then I can combine my constants here. 1 plus 1 is 2. So if I simplify this, I would have x squared minus 2x plus 2. Now I still have to multiply this trinomial with the x minus 4. So in the end, I still have to multiply x minus 4 times x squared minus 2x plus 2. So let's distribute. X times x squared is x to the third. X times -2x is -2x squared. X times 2 is 2x. Now I distribute the -4 to all three terms. -4 times x squared is -4x squared. -4 times -2x is +8x, and -4 times 2 is -8. So finally, to write my final polynomial in standard form, I know standard form means highest degree to lowest. So the highest degree is x to the third. I notice that I can combine some x squareds. I have -2 minus 4 more. So that would be -6x squared. Looking at my x's, I have +2 plus 8 more, which would be +10x. and then I have a minus 8 at the end. So this would be my polynomial in standard form.